Hello there! A new version of the Maxwell plugin for Rhino has been released. It is version 5.2.6.2. So I'm going to show you some of the new features that are included in it. First, I'm going to talk about the new options included with the native Rhino lights. So you can make the most out of the Maxwell plugin and the Maxwell options using those lights. Then I'm going to talk about the camera visuals, this button here, and some options related. And then I'm going to show you how to export and render animations made with Bongo with this version of the plugin. Let's see it. Okay, let's start with the lights. As you may know, Maxwell will translate all the lights here except for the directional light, which has no proper translation into Maxwell, but all the rest can be used by plugin and can be used directly. If you just, for example, start with this rectangular light, I'll select it, and Maxwell will take this color and this intensity to create an Maxwell emitter, as you can see here. You may wonder what this value is in Maxwell, because in Maxwell we use units for the lights. In this case, 1 means 100 candelas, so it will work as a multiplier. If you set it to 2, it will be 200 candelas. You may also want to enter different values or different units for these lights. So for that, you have to go to the Maxwell properties, and here, instead of by Rhino, you can select Maxwell area light. In this case, you will see more controls for the color. You can use the color picker as always, and that will be copied to the Rhino properties. But you can also use the color temperature by Kelvin by unclicking this, and then this will become active. So you can, for example, enter this value, typical value from bulbs. So you have more freedom with the color of the lights. And also you can change the different units used for the emitters. You can use power and efficacy, typical from real life bulbs. Also lumens are more common lately. You can use lux, which depend on the area of the emitter, because this is lumen by square meter, and then candelas, or luminance, which is candelas per square meter too. Okay, for the rectangular light, you can also make it work as an HDR light, which lets you emit light using an image instead of just a color. This can be useful for TV screens or any kind of screen, or you can also, for example, if I change to this image, you can make softboxes easily. And also in this case, you have these controls to rotate or tile the image. So you can, for example, make something like this, which can be very useful for getting nice reflections, like professional softboxes or things like that. In this case, we don't have units. We just have a multiplier of the intensity of that image. Let's now see the next light type, the linear light. In this case, okay. It offers very similar options than the area light. Let's check them. As the light type, we can choose from the same options, but let's see the HDR light, as it offers some extra options here. In this case, as you can see, the light is translated into a cylinder, and the texture is wrapped around the cylinder. In this case, I have chosen a gradient image from pink to orange, and you can see the seam is located here. This rotation around axis parameter will let us rotate that seam or texture, the whole texture around the cylinder. This other parameter will rotate the texture in the UV space of the texture. For example, if I type 90 here, we will see the gradient from the bottom to the top of the cylinder, and we will be able to tile it if we use the tile options. But the rest is very similar as the rectangular light. Let's now see the point light. Okay, I'm going to turn this one off and the point light on. See? Okay, as you can see, this one is translated into a sphere, and here we will have some additional options to control that sphere. For example, these two, the diameter and a number of segments, will show up in all these types. We will have the same types, area light and HDR light, but we will have these extra controls here. This lets us control the dimension of the sphere. We can make it bigger or smaller with this control, and we can change the resolution of this of the sphere with this other control. For example, if we lower it down, it would look less like a sphere. But this is important because the lights will be faster if the emitter is lower poly. However, we offer this option in case the point light is visible in the render, so you can make it really look like a sphere. For example, if we raise this value, the point light will look more like a sphere. In this case, as you can see, that the texture is wrapped around the sphere. It has two poles, one at the top and the other one at the bottom. So you can use 360 degrees images. The same one you use for the environment maps can be used here. And this parameter, the rotation around axis, will rotate the texture around the vertical axis of the sphere. For example, in this case, if I use 300, we will see this window here will move here. Okay, so we can rotate around the vertical axis of the sphere. The rest is basically the same as in the previous light type. Okay, let's now see the last one, the spotlight. I'll turn the point light off and the spotlight on. Okay, in this case we use the cone of the spotlight, and the geometry of the cone will affect also the light in Maxwell. So you can change its geometry, and the highlights and the fall-off will be affected and will be taken into account by the shape of the cone. Okay, we have quite different options from before. In the case of the spotlight, Maxwell can translate it into a normal spot, in an image projector, or an IES file. Okay, if we don't set any image here, the cone will be translated, the spotlight will be translated as a normal spot, and we can find some extra options here. For example, we can change the follow-up type from linear, square root. We have different options that will change the look of this fall-off here, as you can see. Also, this blur parameter will affect the shadows of the objects, the shadows that this spotlight projects. So pay attention to this. I'm going to change the blur parameter. You will see the shadow will be much softer than before. Okay, and we also have the same color and intensity values that as we have before in the other lights. Okay, we have this parameter too, and that we will see with an image here. Let me load this image. Okay, currently we see it quite blurred because we have this high blur value here, but let me turn it down so you can see the image clearly now. If we increase this intensity, we will see it better. Okay, and this the color here will affect also the image. It will tint the image. For example, if I change to Kelvin and type something warmer, you will see the image will also tint in warmer colors. So you can control the image like that. And this parameter here will help you rotate the image around the axis of the cone. For example, if I type 90, you will see the image will be rotated 90 degrees. Okay, let's see now the IES options. Okay, as you can see, we have less options. You can load the IES or LDT files here, and well, you have the intensity multiplier. If you set it to 1, we will have the intensity specified in file, and then it works as a multiplier. If we set it to 2.5, it will be halved, and if we set it to 2, it will be double, obviously. We can also change its color with these options, and the rotation around axis will also rotate the pattern of the IES file around the axis of the cone. As you can see in this case, the pattern is a little bit elongated along this axis. So we can make it back to 0. You see the pattern has changed its shape. Okay, and that's all for the lights. Okay, let's now see the camera visuals button. This button will let us see the final framing of the render in the viewport. So as you can see, it has displayed now a frame that fits perfectly the viewport. And that's because by default the resolution of the render is determined by the window, by the viewport we are rendering. But that's something that can be changed if we set it to custom resolutions like this. So now you can see the real framing of the final render. Or if you use these shift lens options, you will see also that the frame can be outside the viewport. If that happens, the frame will turn red, so you can notice it's out of the visible part in the viewport. When this happens, you may find it difficult to frame and to locate the camera precisely. So we have added this option here, displaying fire, which normally is set to match viewport. So if now I click fire, it will render the exact same view as you have in the viewport. But you may want also to preview the final framing of the render. So in this case, you can change it to final render, and when you click fire, it will display exactly what will be visible in the render. taking into account the special resolution and also the shift lens options. So for example, if I move it here to 25.2, we will see the view will be moved accordingly. And as well, this special head-up display we have here. So you can see, for example, if I change it back, it will move up. So this can be pretty useful for setting up the render in detail without having to launch any render or things like that. For example, in this case, I can move it back and I can frame it easily without having to launch a render. Pretty useful. Okay, let's see the animation in Bongo. I have created this simple scene with just 9 frames. It's animated, so we can see it quickly how it sports, and we don't spend much time waiting. In this case, it's important that you set the output options first. For example, the output folder, the output name, the format, all the channels you want to get before launching the renders or exporting the frames of the animation. But apart from that, it's very simple. You just have to go to the render animation window from the Bongo menu, and well, Maxwell will take into account the number of frames you have set here and here. All these will be taken into account. You can now select Maxwell for Rhino here, and this side here, all these options will be disregarded. Rhino will keep exporting these BMP files or JPG, but it won't be very meaningful, and the video file won't be created. So we just have to press the render animation, and the frames will be exported. They are being exported now. The MXS files are being generated at this very moment. So when it finishes, the plugin will show this window. It will show the output folder here, so you can easily open its folder. As you can see, all the MXS files have been generated now, and we could just cancel the process here. We could work with those files and put them to render in the network or the cloud or Maxwell manually. But the plugin also offers some options here to render them directly in Maxwell, in the network, or the cloud. So the cloud will generate a cloud job in the monitor, Maxwell monitor. This will generate an animation job for the local network, and this will launch Maxwell render, and all the frames will be rendered in sequence using the frames mode. You can change the frames you want to render, or change the time limit or the sampling level limit you want to use in this case. So for example, I just click render animation, and Maxwell will be open in frames mode. So the frames will be rendered one after the other. This is something you can do manually too. You can load one of the numbered frames of the animation and just type here in this frames box. For example, if you want to render from frame 0 to render to frame 5, you type 0 dash 5, and you can also then enter comma frame 8 comma whatever you want, and the renders, as you can see, are being rendered in sequence. When one is finished, the next starts until it reaches the last frame and it stops. And that's basically all. We try to make it quite simple and easy, so you can now export and render your animations directly from the plugin and launch the renderers easily. I hope you enjoyed the video and have fun. Bye bye.